Good evening, and welcome to the Song of Urania, a podcast about the history of astronomy with new episodes every full moon. My name is Joe Antonini. In the last episode, we began to look at the astronomy of ancient Babylonia and the fundamental problem of the calendar, namely that the month does not evenly divide the year. Tonight we will take a more mystical turn and look a little more carefully at how astrology developed in parallel with the astronomy of ancient Mesopotamia. The evidence we have from both ancient Mesopotamia and other cultures around the world suggests that astronomy originally developed for what we moderners might call secular purposes. Calling these purposes scientific might be going a bit too far, but perhaps the earliest astronomy could fairly be called a form of engineering. The motions of the heavens were the best means the ancients had of regulating agriculture, as it must be because, of course, the motion of the sun is inseparable from the progression of the seasons and the growth of crops. So astronomy originally developed to set the calendar. But of course, nothing is clean in history, and from the start, people have also associated the heavens with the gods as well. As I discussed in the last episode, the earliest records we have of the constellations associate them with various gods, but it is some time before what we might call true astrology develops. The development was gradual and may have occurred in parallel with the development of the local religions in ancient Mesopotamia. Of course, from the start, various constellations are associated with various gods, but early on, the constellations get grouped together into three realms. A northern realm, which is associated with the god Enlil, a middle realm that straddles the celestial equator, which is associated with Anu, and a southern realm, below the equator, associated with Enki. These divisions were such that the sun, moon, and planets all spent 1/3 of their time in each realm. Now, these gods, Enlil, Anu, and Ea, or Enki, were no ordinary gods. Anu, for instance, was the prime mover, the god who created all things, from whom divinity itself had its source. In fact, the divine power that all gods possessed was called Anutu, in reference to the fact that they derived this godly authority from Anu. And his name is actually synonymous with the sky and the heavens themselves, which can make things a little confusing. Anu comes closest to the monotheistic conception of God. Anu was unique in that he had no creation story. He simply always was and always will be, much like the God of Abraham and Moses. More relevant to human affairs, at least originally, was Enlil, the god of the northern sky. While Anu creates all things, it is Enlil who separates the heavens from the earth and is enthroned as chief of the gods, at least until Babylonia comes to dominate its neighbors in Mesopotamia by around 1600 BC, when its local god Marduk comes to occupy the rank of chief of the gods, and then displaced Enlil to a more ethereal position like Anu. To analogize with Greek mythology, Anu occupies a position similar to Gaia, who is the source of all other gods in Greek mythology, but who otherwise does not much interact with humanity. Enlil, and later Marduk, occupies a role closer to Zeus, as both are viewed as leaders of the gods and occupy themselves frequently in human affairs. Lastly, Enki, also called Ea, the god of the southern skies, is another of the great gods that form the so-called triad of heaven in Mesopotamian mythology. Enki was the god of the waters. One might identify him loosely with Poseidon in Greek mythology, but unlike Poseidon, Enki was not so much identified with the oceans, but instead a more fundamental kind of water, namely the water beneath the earth, on which the earth itself was supported. In the cosmology of the ancient Mesopotamians, also shared by the ancient Israelites, the world was flat, with the dome of heaven above it, and was supported underneath by an ocean. You could, of course, look out and see that the world was flat, and look up to see the dome of heaven, but the waters underneath the earth were also obvious enough to the residents of the Fertile Crescent. They had to dig wells for their water and knew that if you dug deep enough, water would eventually flow forth. Enki's domain was identified with this more fundamental water than the ocean of Poseidon. And because this life-giving water springs forth after persistent digging, Enki also became associated with wisdom and the magical arts. So we have a division of the world into three parts: the waters, the earth, and the heavens. And this division is itself reflected in the heavens as well, with each star becoming associated with one of the gods of the triad of heaven. But of course, the Babylonian pantheon contains far more than three gods. In fact, over most of the recorded history of ancient Mesopotamia, other gods played a more integral role in human affairs. I have already mentioned one, Marduk, and mentioned another in the last episode, Inanna. But there were many others. The most important of these more immediate gods were associated with the planets. This is really quite natural. The heavens themselves are vast and largely static and unchanging. They form the celestial backdrop against which the planets move. And likewise, the gods associated with them form the theological backdrop against which the gods closer to human affairs act. Marduk, who eventually becomes chief of the gods, is associated with Jupiter, who is, of course, also the chief god in the Roman pantheon. And Inanna, a goddess of love and beauty, becomes associated with Venus, just as in the Roman pantheon. But Mars was associated with the Babylonian god Nergal, who is the god of pestilence, unlike in the Greek and Roman pantheons, where Mars is associated with the god of war. Nevertheless, in both cases, Mars is viewed as an unlucky planet, almost certainly due to its distinct reddish hue. But like Venus and Jupiter, Mercury and Saturn both line up fairly well with the Babylonian associations as well. Mercury is associated with Nabu, who is the god of scribes and messengers, and Saturn is associated with Ninib, the god of agriculture. Given that Mercury quickly flits to either side of the sun, it is not all that much of a surprise that it gets associated with messengers across several cultures. As for the association between Saturn and agriculture, I can only speculate that because that is the slowest of the visible planets, it might represent the slow but steady work of the Earth in producing vegetation for people to eat. But that is pure speculation on my part. Of these, Inanna, who later becomes known as Ishtar, occupies a particularly special place. The planet Venus seems to have had an outsized position in Babylonian astrology and was considered to be of astrological importance closer to the sun and the moon than the other four planets. Records of the appearance and disappearance of Venus in the evening and morning skies appear far earlier than records of any of the other planets. Now, early on, we do not have much evidence for any sort of systematic astrology other than this loose association between the heavens and various gods. But one significant change came sometime after the Assyrian conquest of 911 BC. For this, we will have to look at Mesopotamian writing called cuneiform. One of the features of cuneiform text is what is called a determinative. This is a character that precedes a word and specifies the general category the word belongs to. Determinatives are common in languages which use ideograms. Egyptian hieroglyphs, Chinese characters, and signs in American Sign Language all have some form of determinatives. These determinatives are not pronounced, but help to disambiguate written texts. In cuneiform texts, the categories represented by its determinatives were fairly broad. One determinative represented buildings, another represented trees and anything made of wood. There was one for countries and another for birds. And up until the Assyrian conquest, the determinative used for the planets was called mul, which just means star. Every star name was preceded by this determinative mul. In fact, the Pleiades star cluster was simply called Mul Mul, which literally translates to star star. Fairly appropriate. At any rate, originally the planets were considered to be a particular kind of star. But after the Assyrian conquest, something changes in the cuneiform. The determinative changes to Dinger, which means God. From this point forward, the planets are no longer viewed as a kind of star, but as a kind of god. It is in this Assyrian period that astrology becomes more complex. The Babylonians had been recording omens based on the heavens, but their omens were limited to the motions of the moon. Years that needed extra months were bad, and the motions of Venus, which was perceived at the time not so much to be a planet, but more like the sun and the moon. But by this period, Babylonian astronomers began recording the positions of the other planets in addition to the position of the sun and the moon. and the positions of the planets were a fertile source of interpretation to predict what was to come in the future. As civilization was developing and the world was growing to be more complex, it is perhaps no surprise that people in turn developed ever more complex means to understand what was happening in the world around them and how they should act. The general practice of foretelling future events by interpreting patterns in the natural world is what is known as divination, and the ancient Mesopotamians used many different forms of divination. It was a common enough practice in the ancient Near East that divination is explicitly forbidden in not just one, but two of the books of the Torah, the book of Leviticus and the book of Deuteronomy. In ancient Babylonia, common divination techniques included examining the livers of sacrificed animals or their lungs, and studying the flights of birds. In addition to these practices was the art of interpreting omens, which were more irregular events than divination. A priest could perform divination whenever he so chose by sacrificing an animal and examining its liver or looking for splotches on its lung. But omens simply presented themselves whenever the gods decided to present them to humanity. An omen could take the form of a minor earthquake, an unusual birth, say of 2 sheep fused at the spine. But a principal source of divination and omens came from the heavens. The configuration of the heavens on any given night could be interpreted by the priests, and the heavens also presented irregular omens that could be interpreted as well: meteors, eclipses, halos, and more. I would like to make it clear, however, that this distinction I am drawing between divinations and omens is a modern distinction. When writing about the meaning of the positions of the planets, Babylonian astronomers always used the same term. Today we translate it as omen. One of the advantages of studying the positions of the planets was that their motions appeared to be fairly irregular. While they generally drifted west to east relative to the background stars, sometimes they moved faster and other times slower. Sometimes they even stopped and went backwards. Sometimes they got brighter and sometimes they dimmed. While we know that these motions are in fact quite regular, detecting these patterns appears to have taken the Babylonians many centuries because the periodicity of their motions is many decades in length. Now, as I warned you on the first episode, we will spend a fair amount of time discussing astrology on this podcast, so it's important to understand some of the qualities of astrology in the ancient world. Today, when we think of astrology, we normally think of the horoscopes in the newspaper next to the word jumble or the crossword puzzle, at least for those of us of a certain age who grew up when people still regularly subscribed to a physical newspaper. Or perhaps if you grew up in Puerto Rico, watched Walter Mercado's television show. Well, it doesn't take too much thought to realize that there are some pretty big problems with this kind of astrology. After all, there are only 12 horoscopes printed, one for each sign. So if these horoscopes were valid, you would have to believe that you could break the entire population of the world into 12 groups, and essentially the same things would have to happen to everyone in each of those 12 groups. Obviously, any predictions you could make that would apply to such a vast population would have to be hopelessly vague. Now, this argument is not entirely fair to astrology, because someone who is really deep into astrology will know that other factors aside from your sign are important when constructing a horoscope. And of course, we will get into all this in much more detail in later episodes when we look at the astronomy and astrology of the Middle Ages. But this kind of astrology, what we think of as astrology today, is what can be characterized as personal astrology. In personal astrology, the motions of the heavens reveal secrets about your personal destiny, both over the course of your life and right now, today. Personal astrology in the West is really a development during the medieval period. We have no evidence for personal astrology in ancient Mesopotamia, and very little evidence for it in general in the ancient world. The concern of ancient astrology was instead what might be termed judicial astrology, though this gets a slightly different meaning when applied to astrology in the Middle Ages. Here, the heavens are not concerned with an individual's day, week, or even life. Instead, they are only interested in the grandest of events: wars between nations, famines, plagues, deaths of kings. The only individual who warrants any attention whatsoever from the heavens is the king, and even then only on matters of life or death. So what do these omens say? Well, let's read a few to get a feel for them. One reads, quote, Mars is visible in Duzu. It is dim. When Mars culminates indistinctly and becomes brilliant, the king of Elam will die. When god Nergal in its disappearing grows smaller, like the stars of heaven and is very indistinct, he will have mercy on Akkad. When Mars is dim, it is lucky. When bright, unlucky. When Mars follows Jupiter, that year will be lucky. End quote. Every detail of the configuration of the planets was important when interpreting an omen. The constellation that the planet was in, how bright it was, its relationship to other planets. These details would all have implications for the meaning of the omen. The land was divided into 4 directions. In the south was Akkad, which contained Babylonia. In the north, Subartu, which contained Assyria. In the west, Amurru, which contained the Amorite kingdom in modern-day Syria. And in the east, Elam, whose king was to die according to this omen. Elam was beyond a mountainous border where the Elamites lived in modern-day Iran. Omens could apply to only some of the lands, so seeing a bad omen may have been okay if it applied to those other lands. But not all omens were bad. Another reads, quote, When Jupiter passes to the west, there will be a dwelling in security. Kindly peace will descend on the land. It appeared in front of Alul. When Jupiter assumes a brilliance in the way of Bel and becomes Nibiru, Akkad will overflow with plenty. The king of Akkad will grow powerful. End quote. This makes sense, because Jupiter was seen as a good omen. And of course, the planets were not the only source of omens. Later in the same text we read, quote, When a great star like fire rises in the east and disappears in the west, the troops of the enemy will be slain in battle. End quote. This great star refers to a meteor. Another tablet records a meteor sighting and interprets it as well as an auspicious omen. Quote, After 2 hours of the night had passed, a great star shone from north to south. Its omens are propitious for the king's desire. The king of Akkad will accomplish his mission. End quote. The moon also figured in the interpretation of omens, but mostly in relationship to the calendar. As we discussed in the last episode, years in which the moon came out of sync with the solar calendar and needed an extra month added were seen as bad. But we didn't so much talk about a problem that exists on the other side, namely that the length of a day does not neatly divide the length of a month. Because the Babylonians marked the start of their new month on the evening when they could first see a crescent moon after a new moon, the number of days in the month could have been either 29 or 30. The actual length of the month from new moon to new moon is almost exactly halfway in between, at 29.53 days. But this is only an average, and the time between new moon and new moon varies and can be as short as 29.12 days or as long as 29.93 days. But because the Babylonians had to have either 29 or 30 days per month exactly, errors could accumulate, so that some months may have had 28 or 31 days. These errors could further be compounded if it had been cloudy at the beginning of the previous month, and the previous month had then begun on the wrong day. So just as there were years that needed extra months, there were months that needed extra days, or days removed. And these irregular months were considered to be bad omens. Fortunately, with careful observation, the Babylonian astronomers could anticipate them by tracking when they saw a full moon. If it occurred on the 14th day of the month, all was well. But if it came on the 13th of the month would be short, and if it came on the 15th or later, it would be long. The way this was observed in practice was that in a normal month, on the night of the 14th, the moon would be just shy of full at sunset, and so would rise before the sun sets. And so both would be visible at the same time, the sun in the west and the moon low on the horizon in the east. But at sunrise the following morning, the moon would have just passed full, and now would set just after sunrise. So, in a normal month, the moon would be seen with the sun at both sunrise and sunset. The Babylonians recorded this by saying that the moon was seen with the sun. By contrast, if the moon rose after sunset on the 14th, that meant that the full moon had already occurred and that the month was short. It was even worse if the moon was seen with the sun at sunrise on the 13th. At the other extreme, if the moon set before sunrise on the 14th, that meant that the full moon had not occurred yet and that it had to happen on the 15th, making the month long. Let's take a look at some of these moon-related omens. As an example of a happy omen, quote, "When the moon appears on the first day, there will be silence and the land will be satisfied." End quote. So what this means is that if the length of the previous month had been miscalculated, the moon might not appear when it was expected to on the first day of the following month. But if it did, as it did in this omen, all was well. Another reads, quote, "When the moon reaches the sun and with it fades out of sight, there will be truth in the land, and the son will speak truth with the father. On the 14th, the god was seen with the god. When the moon and sun are seen with one another on the 14th, there will be silence, the land will be satisfied. The gods intend Akkad for happiness." End quote. I feel warm and fuzzy reading that 3,000 years later. But not all omens were so favorable. An unfavorable lunar omen reads, quote, "When the moon does not wait for the sun and disappears, there will be a raging of lions and wolves. On the 15th, it was seen with the sun." End quote. And here is an even more catastrophic omen. Quote, "When the moon and sun are seen with one another on the 16th day, king to king will send hostility. The king will be besieged in his palace for the space of a month. The feet of the enemy will be against the land. The enemy will march triumphant in his land. When the moon on the 14th or 15th of Duzu is not seen with the sun, the king will be besieged in his palace. When it is seen on the 16th day, it is lucky for Subartu, evil for Akkad and Amuru." End quote. The position of the moon relative to other planets could also figure into the interpretation of omens. In particular, a halo seen around the moon was seen as significant. One interpretation of the halo was as a sort of fence. Another planet being enclosed in that fence was astrologically significant. For example, quote, "When a halo surrounds the moon and Jupiter stands within it, the king will be besieged. The halo was interrupted. It does not point to evil." End quote. So, fortunately for the king in this case, the astronomers observed that the halo did not form a complete circle. There was a hole in the fence. So although the king would be besieged by his enemies, there was a way to escape. But not all kings were so fortunate. Another omen reads, quote, "When a halo surrounds the moon and Mars stands within it, a king will die and his land be diminished. The king of Elam will die. Mars is the star of Amuru. It is evil for Amuru and Elam. Saturn is the star of Akkad. It is lucky for the king, my lord." End quote. So once again, the astronomer's king has gotten off easy. But eventually, his luck would run out. Certainly, the most important and malevolent omen to the Babylonians was the lunar eclipse. It's not hard to see why. A lunar eclipse would have been an especially disconcerting event to any astrologically minded people. On a night where the moon is supposed to be full and luminous, illuminating the land, it gradually, over the course of a few hours, disappears, as though it were being devoured by some invisible creature. After it has nearly disappeared from sight, it begins to re-emerge all at once, but not looking as it normally does, but instead as an eerie, bloody shadow of its former self. It takes on a dark, blood-red hue. After an hour or two, the blood color fades, and the usual moon begins to re-emerge, as though being disgorged by the creature that ate it. So it is no surprise that the Babylonians regarded lunar eclipses as uniquely terrible omens. In fact, during particularly ominous eclipses, Babylonian kings would occasionally go so far as to temporarily abdicate the throne and choose a commoner to rule as king for the duration of the evil omen. During the Assyrian Empire sometime in the early 600s BC, one record states, quote, "If it is acceptable to the king my lord, A commoner should be appointed to the bishopric as previously. He should offer the daily sacrifices before the high altar. On the days of the monthly feasts and the feast of the greeting of the temple, he should pour out the incense on the censer stands before the Lady of Akkad, and then, should the moon bring about an eclipse and affect Akkad, he should serve as the king's substitute." End quote. A later letter from a priest to the king describes the activities of the substitute king in more detail. Quote, "The substitute king, on the evening of the 14th, took his seat upon the throne, then spent the night of the 15th in the palace, during which the moon affected him with the eclipse. He entered Akkad safely on the evening of the 20th, and took a seat upon the throne. In the light of day I had him recite the traditional formulae of the scribal guild. He took upon himself all the signs of heaven and earth, and assumed the hegemony over all the universe. This eclipse, which the moon brought about in the month of Tebet, concerned the land of Amurru. The king of the land of Amurru will die, his land will diminish, or, in another interpretation, will disappear. Either the king of Kush, or the king of Tyre or Mugalu, must meet the appointed death, or the king my lord will capture him. The king my lord will diminish his land, the woman of his harem will enter the service of the king my lord. The king my lord should be gratified. However, the king my lord should be careful, and his vigilance great." End quote. What happened to the commoners after the time of peril had expired? Sadly, the unfortunate commoner was made to expire as well. We do, however, have a record of one commoner who escaped this fate. An ancient Babylonian text called the Chronicle of Early Kings records the tale of one king by the name of Ira-Amiti. Ira-Amiti was given an especially sinister omen, generally interpreted to be a lunar eclipse, and abdicated his throne and temporarily placed his gardener on the throne as a substitute king in his place, even going so far as to give him the crown. Unfortunately, the hapless Ira-Amiti died that night, and his gardener, Enlil-Bani, refused to give up the throne and reigned for another 22 years. The text spends only 6 lines or so on the story of Ira-Amiti, but nevertheless spends some of that space to record that Ira-Amiti died that night while eating hot porridge in the palace. Ancient texts tend to be fairly laconic, and writing was expensive, so details they include are almost never extraneous. Some have interpreted this statement to mean that the liquid was boiling hot and was in fact the cause of Ira-Amiti's death. The real sin that Ira-Amiti may have committed was remaining in the palace after he had abdicated the throne. Now, Ira-Amiti ruled from 1868 to 1861 BC, but the Chronicle of Early Kings was written many centuries later, so whether or not this story happened exactly as it is recorded, particularly with the death by hot porridge, can't really be verified. This may have been more of a warning to contemporary kings to avoid the fate of Ira-Amiti. But the gardener, Enlil-Bani, was the exception. Although the texts are somewhat oblique about the fate of substitute kings, all the evidence suggests that they were executed so that the original king could return to the throne. In this way, the omen that the king would die became a self-fulfilling prophecy. This was not the only sort of self-fulfilling prophecy during lunar eclipses. One king was murdered by his own son, who chose a lunar eclipse as the appropriate moment to execute his dastardly deed. But the parricide did not succeed in usurping the throne. Instead, it was one of his brothers who succeeded his father and became king. Well, at any rate, predicting lunar eclipses was clearly of utmost importance to Babylonian astronomers. Fortunately, most lunar eclipses are not all that hard to predict. Once you have observed a lunar eclipse, there will be another lunar eclipse 6 months later, and another 6 months after that, and the cycle will continue with a lunar eclipse occurring every 6 months, 5 or 6 times in a row. To understand why this is, it helps to ask why lunar eclipses don't occur every month. After all, a lunar eclipse is caused by the Earth coming between the sun and the moon and casting a shadow on it. And every time it is a full moon, the Earth is between the sun and the moon, so there should be an eclipse, right? But the problem is that the orbit of the moon is slightly inclined relative to the orbit of the Earth by about 5 degrees. Another way of putting it is that the path of the moon on the sky is slightly tilted relative to the path of the sun on the sky, the ecliptic. So when the moon is full, most of the time it is slightly above or below the ecliptic, and it is not directly behind the Earth and therefore remains illuminated. But there are two special points on the moon's path across the sky where it intersects with the ecliptic, which must be the case since any two great circles must intersect at 2 points. These special points where the moon's orbit intersects the sun's are called nodes. Now, most months, the moon passes through the nodes with no problem. The moon is at some random phase, say a waxing crescent or first quarter, and so is next to the Earth, not behind it, and still gets illuminated. But if the moon happens to be full when it passes through the node, it will be directly in line with the Earth and the sun and will become eclipsed. So if the moon is full as it passes through a node, you get a lunar eclipse. Well, what happens the next month? 1 month later, there is another full moon, but now the moon has moved 30 degrees away from the node, 30 degrees being just 1/12 of a circle. So you're nowhere close to a node and there's no eclipse. 2 months later, you have another full moon, and the moon is now 60 degrees away from the node. No eclipse. And so on until you get to 6 months after the first eclipse. Now you have another full moon and are 180 degrees away from the first node. But remember, there are always 2 nodes, and they are 180 degrees away from each other. So 6 months later, you have a full moon, and the moon passes through a node, and there is a lunar eclipse. Of course, 6 months after that, it is 1 year later, and the moon is right back where it began, a full moon passing through a node, and the cycle repeats itself with another lunar eclipse. You might wonder, why then does this series ever end? If you have one lunar eclipse, won't you have another after 6 months, and then another 6 months later, and every 6 months until the end of time? Instead, the cycle stops after only 5 or 6 eclipses. What's going on there? Well, the first problem is that, as I have said, maybe a bit monomaniacally, the month does not neatly divide the year. 6 full moons are somewhat less than half a year. So, after 6 full moons, the moon won't actually be 180 degrees from where it started. It will be closer to 170 degrees away from where it started. In addition to this, it turns out that the nodes, the points where the moon's path on the sky intersects the ecliptic, are themselves not stationary. The nodes drift westward over time with a period of about 18.5 years. The cause of this is essentially a torque exerted by the sun on the orbit of the moon, which causes its orbit to wobble or precess slowly over time. We will get into this phenomenon in much more detail in a later episode when we talk about Isaac Newton and the three-body problem, but that will be many moons from now. Now, it turns out that these two effects almost cancel each other out, but not quite. The relative difference is about 4 degrees over 6 months. The end result is that if you have a perfect lunar eclipse on 1 month, 6 months later, the full moon will be a little bit away from the node by about 4 degrees, and the eclipse won't be quite so perfect. Now, the Earth's shadow is fairly wide, so even if the moon is 4 or even 10 or 12 degrees from the node during a full moon, you can still see an eclipse. But it won't last quite as long, and the moon might not get quite as dark. After another 6 months, the moon will be just barely in the Earth's shadow, but in an outer part called the penumbra, where it is still partially illuminated. And after another 6 months, the node will have moved enough that during full moon, the moon will be too high above the ecliptic and will still remain fully illuminated by the sun. The ancient Babylonians did not have a sophisticated model for lunar eclipses like this, but they were able to recognize patterns and notice that if they saw a lunar eclipse, there would follow a series of 4 or 5 more every 6 months after that. Because of their astrological importance and periodicity, keeping records of lunar eclipses was critical. The Enuma Anu Enlil, which is the largest set of omens that the Babylonians produced, has this to say, quote, "When the moon is eclipsed, you shall observe exactly the month, day, night watch, wind, course, and position of the stars in whose realm the eclipse takes place. The omens relative to its month, its day, its night watch, its wind, its course, and its star you shall indicate." End quote. Because most eclipses could be predicted, astronomers would watch carefully to observe how they appeared, because other weather events could turn an unfavorable eclipse into a favorable omen. One omen reads, quote, "To the king of countries, my lord, thy servant Belusur. May Bel, Nebo, and Shamash be gracious to the king, my lord. An eclipse has happened, but it was not visible in the capital. As that eclipse approached at the capital where the king dwells, behold, the clouds were everywhere, and whether the eclipse took place or did not take place we don't know. Let the Lord of Kings send to Ashur, to all cities, to Babylon, Nippur, Uruk, and Borsippa. Whatever has been seen in those cities the king will hear for certain. The great gods who dwell in the city of the king, my lord, clouded the sky and did not permit to see the eclipse. So let the king know that this eclipse is not directed against the king, my lord, nor his land. Let the king rejoice." End quote. So the astronomers had predicted that an eclipse would occur, but luckily for the king, it was cloudy that night, which protected his realm from the unfavorable effects of the eclipse. Indeed, Babylonian kings would send astronomers to various ends of the empire to see where the eclipse was visible. Other circumstances could also change the outcome of an eclipse. Another omen reads, quote, "If, during an eclipse, Jupiter remains visible, it is a good omen for the king, because in his place a high-ranking official will die. Did not the king notice that before a month had passed after the eclipse, his chief judge died?" End quote. Now, one curious phenomenon that I haven't mentioned yet is that when you see the first lunar eclipse in a series, you aren't actually guaranteed to see all 5 or 6 eclipses in that series. Sometimes it happens to be day when the next eclipse occurs and you miss it. So, if you're just recording when you see lunar eclipses, you'll find that they are sometimes 6 months apart, but other times a year apart. Ancient Babylonian astronomers noticed this, but were nevertheless able to infer that those unobserved eclipses must have actually happened, just like the times when it was cloudy and the eclipse couldn't be seen. They knew that it wasn't as though the eclipse hadn't happened just because they couldn't see it. The eclipse really had happened, it just wasn't possible to observe it. And I believe that this is actually a critical development in the history of science. There are certain extraordinary times that occur every so often throughout the history of science, where some pattern is noticed, but occasionally the pattern appears to be violated. And the scientist, seeing the violation of the pattern, rather than discarding the pattern, trusts their theory enough that they actually believe that the missed occurrence is a failure of observation rather than a failure of the theory, and that there is some missing event or object which was for some reason not observed, but must be inserted to make the pattern work. These invisible lunar eclipses are the first instance of such an insertion, but they are far from the last. In the first episode, I briefly discussed the discovery of Neptune. Neptune was discovered because astronomers had noticed an anomaly in the orbit of Uranus. Rather than discard Newton's theory of gravity, they realized that they could keep the theory if they inserted an extra, so far undetected planet outside of Uranus's orbit. Similarly, in the early days of particle physics, physicists noticed that certain kinds of particle interactions seemed to violate the conservation of momentum. But rather than discard this theory, they hypothesized that there was an extra, new and undetected particle that carried away that missing momentum. This particle was later detected and is today called the neutrino. And we are in the midst of another in astronomy today with a hypothesis of dark matter. Now, this kind of leap of faith does not always work. Sometimes the theory really is wrong. An analogous story to the discovery of Neptune happened at the other end of the solar system, but with an opposite result. By the end of the 1800s, astronomers had observed that there was an anomaly in the orbit of Mercury and could not account for it with perturbations from the known planets. So some astronomers, notably Urbain Le Verrier, hypothesized that there was an as yet undiscovered planet called Vulcan between the Sun and Mercury that was causing this anomaly. Le Verrier and others searched for Vulcan and thought that they had found it on a few occasions, but it turned out that Newton's theory really was wrong. the anomaly in Mercury's orbit was only explained by Einstein's general theory of relativity. Nevertheless, when these sorts of leaps of faith work, they are real triumphs of scientific theory. And the ancient Babylonians provided the first of these in history with their invisible eclipses. Well, we've spent quite a while talking about lunar eclipses, but what about solar eclipses? Solar eclipses are incredible phenomena, even for us jaded moderners. People travel hundreds of miles to observe one, and having done this myself, I can say that it was worth it. It has been said that they make scientists of poets and poets of scientists. And they must have been uniquely significant events for pre-scientific peoples. But Babylonian astronomy does not actually have much to say on the subject of solar eclipses. A few are recorded and have been useful to establish chronologies of ancient Mesopotamia. But some of the recorded eclipses may have actually been particularly bad dust storms because they occurred in the middle of the month rather than at a new moon, which is the only time when it is possible to have a solar eclipse. Although solar eclipses are incredibly dramatic events, they don't have a big place in Babylonian astronomy, simply because they are very rare. A particular patch of land on Earth is only liable to see an eclipse, on average, once every 300 to 400 years. They just weren't observed often enough for the ancient Babylonians to notice any patterns and develop a theory of their occurrence. So, despite the impact a solar eclipse must have had on anyone who saw it in the ancient world, that is all we will have to say on the subject until we get to the astronomy of the ancient Greeks. But it is still some time before we will come to the astronomy of the Greeks. The Babylonians have much to tell us yet. In the next episode, we will look at later Babylonian astronomy, when records become complete enough that Babylonian astronomers could discern decades-long patterns in the motion of the planets. Thank you for listening, and until the next full moon, good night and clear skies.